Hi, welcome back to EduHub Academia, the education for a better future, and to the World of Physics course, lecture number 10, Quantum Mechanics. Let's start by defining quantum mechanics. It is that crucial theory in physics that studies and explains the behavior of matter and energy at the atomic and subatomic level. It is considered a revolution against Newton's theories, which are called classical physics, as demonstrated in the following comparison table. Classical physics, which is often called Newton's physics, treats the particles as deterministic objects with well-defined position and momentum. It governs the macroscopic world like falling apples and planets in orbit. Quantum mechanics, which deals with microscopic world, introduces probabilistic behavior of particles. Those particles that can exist in multiple states simultaneously. And they are waves and particles at the same time, which is titled wave-particle duality. The positions and momenta of particles in quantum mechanics are only described by probabilities until measured. Now, what are the major discoveries and principles of quantum mechanics? First one, the wave-particle duality. And as we mentioned before, electrons, for instance, can be seen as waves or can be seen as particles. They behave as wave and behave as particle. Energy in quantum mechanics comes in packets called quanta. They don't come in continuous flow. They come in packages. The uncertainty principle is another great principle of quantum mechanics, which says that we can never measure the position and momentum of a particle at the same time with perfect accuracy. Measuring one will definitely affect the other, regardless of the distance. You can either get accurate position or accurate momentum, but you cannot get both accurate measurements at the same time. Another principle of quantum mechanics is the entanglement, which means that two particles can become linked even when they are separated. So measuring one of them will instantly affect the other. Superposition. A particle can exist in multiple states simultaneously until measured. When you measure it, the wave will collapse into a single definite state. Thank you very much. Looking forward to meeting you in the next lecture.